Hello friends, in this lecture I am going to explain a very important part of Z transform, how we calculate Z inverse transform, means inverse Z transform for given UZ. This is so much easy. I will tell or explain two methods. One is by partial fraction and one is by convolution theorem in this lecture. Both are easy. So you will decide by yourself which one is easy for you and do it. So we will take one example. Suppose UZ given or anything, whatever given, nothing matter. UZ given. So always you have to calculate UZ by Z. So what is the value? Divide denominator by Z. So 2Z plus 3. This is your first step. Whatever UZ given, divide by Z. So now you know about UZ by Z value is this. Whatever right hand side is there, that is your FZ. Now second step. Second step is do its partial fraction for Fz. Fz means UZ by Z. Whatever will come in right hand side, do its partial fraction. What we have Fz? We do here 2Z plus 3 upon Z plus 2, Z minus 4. So how we do partial fraction? We know very well. 2Z plus 3. So it is A upon Z plus 2 plus B upon Z minus 4. So what is that? 2Z plus 3 is equal to A Z minus 4 plus B Z plus 2. Z is equal to 4. What we have? 4 to the 8 plus 3, 11. 0. 11 by 6 is equal to B. So Z is equal to minus 2. What we have? Minus 2 means minus 4 means minus 1. Minus 2, minus 2, minus 6. This is 1 by 6. This is A value. So now partial fraction you have. Just put here. What is A value? 1 by 6 Z plus 2 plus 11 by 6 Z minus 4. This is your UZ by Z. This is your second step. So what is your first step? Whatever UZ given, divide by Z. Second step, find out Fz. Means Fz is what? UZ by Z only. Do its partial fraction. Once partial fraction over, again take Z that side. What we have? Z upon Z plus 2. 1 by 6 Z upon Z minus 4. Now take inverse Z transform. Take inverse Z transform both sides. You know Z of UN is what? UZ. So Z inverse of UZ is what? UN. So what is Z of UN? What is UN? 1 by 6 constant. Z inverse of Z upon Z plus 2. You know very well. Z of A to the power n. How much? Z upon Z minus A. So it means Z inverse of Z upon Z minus A. What is the value? To the power n. What is A value here? z plus 2. So a value is minus 2. So this is nothing, minus 2 to the power n plus 11 by 6, 4 to the power n. This is the answer. So this is so much easy. Sometimes here contains a square. Suppose z plus 2 is square. So you know square terms comes in denominator for which transform? Z of n is what? Z upon z minus 1 whole square. So square term comes here only. Cube terms comes in n cube, n square. So in that way you have to decide sometimes, but it's so much easy to calculate using this method. So for partial fraction, this is the easiest way to calculate. Just whatever you get given, divide by z, so you will get it fz. Once you have fz, do its partial fraction and then take inverse for each and every part. If you know z transform of some function, then easily you can do it. Same like Laplace transform. Now I am going to tell one more important property, and that is very important and so much useful, and in every transform technique it is there, and that is convolution theorem. For z transform, what is that? If z inverse of un, same like there, Laplace uz, and z inverse of vn is vz, z inverse of uz is un is vn, then what is z inverse of uz into vz? This is un v n minus n, summation varying from m varying from 0 to n. That is simple. If z inverse of uz is un, z inverse of vz is vn, then z inverse of uz into vz is what? Un vn minus 1, summation varying from 0 to n. We take one example. Question. How it calculate? So as usual you did in Laplace transform, we take uz of what? Z upon z minus a. What we take vz? Z upon z minus b, because we have to use convolution theorem. So what is un? Un means z inverse of this. What is the value? A to the power n. What is vn? B to the power n. Now what is z inverse of uz into vz? This is what? Z inverse of its value is um, summation m varying from 0 to n. Means a to the power n, v n minus n. So v to the power n minus m. So now simplify, find out the sum. That's all. M varying from 0 to n. This is a to the power n, b to the power n, and b to the power n. So b to the power n outside. M varying from 0 to n, a upon b to the power n. This is GP series, and sum of n terms of GP series is what? A r to the power n minus n upon r minus 1. Just do this. What is first term? 1 only. R is a by b power n minus 1 upon a by b. Just simplify this one, that's all. You will get the answer. So, using convolution theorem we can find out easily sometimes, and sometimes it's quite difficult, then you use partial fraction method. One more example we will do for convolution. Suppose we have to calculate the z inverse of z square upon whole square. So what is uz we take? Z upon z minus 1. Vz you take z upon z minus 1. Then what is un? 1 to the power n. What is vn? One only. Power n, a nothing matter. Vn also 1. Then what is z inverse of? Use convolution theorem. Summation n value from 0 to n. Un 1. Vn minus n 1. So 1 plus 1 plus 1. How many times? N times. What is the value? N. That's all. So in this way we can use a convolution theorem. So hope you understand. In next lecture I will tell you how we solve difference equation using Z transform. That is last topic of your syllabus for Z transform. Thank you.